Hi everyone. I'm sorry I forgot to record the lesson this morning, but I'll just quickly zoom through this for your peel points on your handout from last week. So the evaluation for the brain localization. So we need to give some evidence to support that there is localization of function in the brain, that it's not holistic, that it doesn't come from all over our brain. And Broca's area gives us a really good um, a bit of supporting evidence in the form of a case study. So we always need to be careful a little bit with case studies. He talks about Tan. And actually, his name Tan is his patient. Le Borgne is his name, but he was called Tan, and the reason he was called Tan, or the reason why Broca called him Tan, was because he was completely unable to produce any words or phrases. All he was able to say was Tan over and over again. He couldn't say anything else. He couldn't produce any other words. And once Tan had died, Broca was able to perform an autopsy and found in the frontal lobe, he found a lesion, which he then named the Broca's area, because he said this must be where I've discovered where speech production is created or is done in the brain, and that therefore I'm going to call it after myself, the Broca's area. So Tan was his most famous patient, but also here's a picture of another patient that he had, Le Long, who was he was able to say a few more words. He was able to say yes, no, three, always, and Lilo, the mispronunciation of his own name. And again, after his autopsy, after he died, he found the same lesion, the same region as the front of the frontal lobe as Le Borgne, as Tan did. So Broca said this is even more evidence of this being correct, that there is this specific part of the brain that is responsible for speech production. There's a couple of YouTube clips on here that you are welcome to have a look at in your own time. This one's interesting. It's a girl who's 19 who had a stroke while she was reading aloud in an English lesson. And the stroke affected her Broca's area, and she has Broca's aphasia. And it's very interesting to see her trying to form words and trying to produce speech. And there's also an interesting video there that you can watch of a lady who is actually having brain surgery, and she has to be awake during brain surgery, so that they can stimulate different parts of her brain so they can see that they're definitely in the right area to be able to perform the surgery, and they stimulate the part of the brain, the Broca's area, that produces speech. So you see what happens when she is speaking, and then they touch a specific part of the brain, and she can't form those words anymore. So that's an interesting couple of little videos to have a look at. Wernicke was a German neuropsychologist, I suppose, and he had a patient. It's not got a name that's so well known as Tan was for the Broca's area, but he had this patient who could speak quite well but was unable to understand the speech of others, and so this was about comprehension of speech. Wernicke said that once he'd had a look at this brain of this patient after they died, he performed the autopsy, and he found damage to the area that was just in the temporal lobe, just the other side of the auditory area, and he called that the Veronicas area. He said that little area there, when that little area there is damaged, what's on our left side? L, left for language. In our left side, if that little part of the area of the brain is damaged, then that means that you're going to be unable to understand speech. It's also interesting talking about Wernicke's aphasia, and there's some different examples of it online, and things to help people cope with it if they have it, or if they are talking to somebody who has it. Some interesting things, and one of the things is that even though they can produce speech, the speech that they produce, it may be more or less kind of grammatically correct, but there are quite often sort of strange or meaningless words that come out at the same time and just make it not, you can tell it's not quite right. And they call this phenomenon word salad, that they can just come out with lots of crazy things. And if you want to have a little look at that, there's a video there of a boy who's been diagnosed with Veronicas aphasia, or aphasia I should say. And just an interesting little clip of that you'll understand what this word salad means. So Veronicas area, the key thing is about the comprehension of speech from others and not having that understanding of it. Okay, so that was a couple of bits of evidence of location of brain, because we could see once we'd looked at the brains that after the people had died that there were lesions in those areas. Great evidence. Here's another bit of evidence. And this is brain scan evidence. So, for example, Peterson scanned patients' brains at the same time as making them do different activities, and he found that different areas of the brain activated depending on the different jobs that were having to happen in their brain at that time. So whether they were having to understand speech, whether they were having to produce speech, the different areas of the brain, the Broca's and the Veronicas areas of the brains lit up on the brain scan and showed there was activity going on in those different brains, in those different areas, sorry. So you can read there, it says he used brain scans to demonstrate how Veronicas area was active during a listening task, so it was trying to understand and comprehend. Oh, sorry, I've got a typo here. Broca's, I should say, area was active during a reading task, so trying to speak out loud, reading out loud, suggesting that these areas of the brain have these different functions. So it's another little bit of supporting evidence that we can see that the brain is active in these different areas depending on what job it's trying to do. There's also some neurosurgical evidence, I'm moving myself out there, which is quite shocking, I guess. In the 1950s, Walter Freeman developed this thing called the lobotomy, which you may have heard of if you've watched any old kind of horror movie type things. The lobotomy was basically where the surgeon would put a big probe, a big needle in the frontal lobe and basically destroy it, move it around, and hope that then stopped somebody from being aggressive. And there's lots of these types of photographs with a lady, looking very sad and unhappy, maybe with schizophrenia, maybe with other illnesses. And there she's just had the lobotomy, and now look, she looks much better afterwards. Well, I think that's a little bit of Walter Freeman's propaganda there, or bias. But certainly lobotomies are not something that happen anymore, because it is quite a drastic thing to remove or destroy areas of the brain to change behaviours. There is one thing that does still happen today, but it is very rare, for people who have extreme cases of obsessive compulsive disorder and depression. So one bit of evidence here is Doherty in 2002, so not even 20 years ago, reported on 44 OCD patients who'd had this thing called a cingulotomy, and it's a neurosurgical procedure that basically just involved lesioning of the cingulate gyrus, which is a little tiny area of your brain right down inside it. And lesioning just means kind of getting rid of it, basically. Just a tiny little burn or laser or whatever, just to get rid of it. So what they found, so you can see this is the picture of it happening with it going into that particular part and then getting rid of that little tiny bit there. A post-surgical follow-up 32 weeks later found that a third had met the criteria for successful response to surgery, 14% for partial response. So that evidence kind of backs up that there are specific little parts of the brain that are responsible for different parts of our behaviour. So just another little bit of research there to back up our localisation of brain function. Now, this chap, Karl Lashley, he did not agree that there was localization of brain function. And the reason he didn't agree was because of some experiments he did with rats. So he was trying to find out where memories are located, and he basically got these rats to learn a maze, and then he lesioned a part of their brain. So he got rid of a part of their brain. What did he find? He found that there were no localized memories. He found that no matter what little specific parts of the brain he took away, the rats could still go through the brain, even with those parts of the brain removed. So actually what he ended up doing was he started finding that if you remove different amounts of the brain, different amounts of the cortex, that's what made the difference. So he removed between 10 and 50% from the rats' brains. And he found it didn't matter where he removed it from. He found that it was just the more he removed, the more chance of a rat not being able to remember how to get around the maze. So it was to do with the extent of the tissue damage. So the more, the worse they were able to do it. So when a lot of tissue was damaged, the ability to learn a maze was impaired. And this is called the law of mass action. So massive amounts, I suppose you can remember it like that, massive amounts of the brain gone equals can't do stuff, but little parts of the brain doesn't make that much difference. That's what Lashley said. So he's not saying it's localization, he's saying it's the amount of the brain that is damaged or taken away. He also talks about the law of equipotentiality, which is something that you'll do probably at the beginning of year 13. And he talks about that the fact that different parts of the brain are actually able to take over from damaged parts. So it might be that one little bit is usually responsible for a certain thing, but if that bit gets damaged, then the brain's clever, plasticity he calls it as well, where the brain goes, okay, well, that little bit can't do that now, so I'll take that over and I'll do that bit. So that's what he found with his rats. But obviously, if we look at this fourth bullet point here, it is done with rats, and there's always that question of can you really generalize what's going on in a rat's brain with what's going on in a human's brain? Can we say that it's definitely going to be the same thing? How much value is there in it? So we've got a few different peel points that we could use here. We've got our brain scan evidence that can support localization of function in the brain. We can see that there's the different parts that are lighting up and more activity going on depending on the different things that are having to happen, jobs that are having to happen, whether it's understanding speech, whether it's producing speech. We've got other supporting evidence as well. So we've got our supporting evidence in the form of case studies like TAN, like Phineas Gage is the other one to remember about that we spoke about at the beginning of last lesson. We've got the neurosurgery with the evidence about OCD patients. So there's lots of other supporting evidence to do with it, but a couple of things to be aware of with the use of case studies, for example, as supporting evidence. TAN was just one man and Phineas Gage was just one man, and actually, can we generalize to the whole population from one case study, from what happened to that one person? We don't know what else was going on with them. We don't know if it can definitely 100% be said that what happened with them would happen to everybody else. So case studies have to be taken a little bit carefully. So hopefully that has helped you to be writing your peel points for your localization of function in the brain. Have a little look back through this video. Also, don't forget you can have a look at the book online, which I put on our post on our post feed a little way back. I'll copy it and stick it back in it again so you can see it again. Okay, hopefully that was helpful, and I hope you have a good day on Friday at school, and I will see you soon.